I want to ask you a question. If you had to choose between two flights, flight A or B, both very similar, same cost, but flight B had a much lower carbon emission, which one would you go for? Show of hands, flight A or flight B? Flight B, of course. The mindset shift for your customers has happened already. People now want high performance and sustainable products. So as developers, it's very important that we keep both of these pillars in mind when we design our products and solutions. So today, I want to start by saying, achieving automation, sustainability, and performance. Yes, we can have it all. But how? That's something we discovered together in this session today. Good morning, everyone. My name is Saumya Dubey. I'm a customer success specialist for automation at Cisco. 3 things about me. I love to work on products and ideas around tech. Traveling and surfing is something I really enjoy. In fact, since I started surfing around 2-3 years back, I felt much more closer to nature. And sustainability, especially environmental impact, has been on my mind. And I truly believe that, in this time, it has to be included in all the designs that we do today, right? So the agenda for today is very simple. This session is high level. We deep dive further with the other speakers, and we have a demo as well planned for you. If you have any detailed questions, I'll be here today and tomorrow, so we can catch up as well. In this session, we discuss about some of the automation use cases, their impact on performance and sustainability, and architecture and design. The main point is how can you include both of these things in your design and architecture so that it can have an impact. Because unless you don't start measuring, how will we improve all of these aspects, right? But before we begin, I want to tell you a story. So there's a girl, when she was really young, she goes for a vacation with her parents to a beach. And she's going to the beach for the very first time. And she looks at the waves, and she sees surfers maneuver over those waves. And she's impressed. Wow. So many years later, she comes back to that beach. Now she has a performance board in her hand. She's learned surfing a little bit. And guess what? She's at the beach, and she sees nothing. There are no waves. There are no surfers. The beach is in a pathetic condition. There's a fishery port there now, and definitely the authorities have not cared about the sustainability aspects. She doesn't know where to go. She's traveled so far. She feels very lost. And that's how I also felt in our industry when I realized the kind of scope 1, 2, and 3 emissions that we have because of our network. But of course, there is good news. As Bernard was saying, we are working on it. A lot of things are happening. A lot of you are as well working on that. And I know everyone has amazing ideas on this one. So let me start with a very simple use case, which you all know about. And I know most of you have it in your networking infrastructures today. Zero-touch provisioning. Very simple. So as we know that most of us have started remote working and prefer hybrid working, and obviously want high-performance, secured application access. And with that, ISPs have a challenge, right? Now, they have to provide that access, and obviously, to do that, what happens that we have to deploy CPEs on site, provision them, and with every different sort of vendor, obviously, we need to send an engineer on site with that sort of an expertise. What's happening here? We're increasing the truck rolls. And to do that, we came up with the zero-touch provisioning, right? And if you see a lot of numbers here, let's focus on just 2 things. This is an optimistic internal Cisco study, which just talks about a very simple scenario where the CPE installation is being done, and then there is a service restoration that is happening. If you see the number on the bottom, you see that it talks about the kind of emission we have with this optimistic scenario. That's 10 kg of emission per month. But if we had ZTP in place, this could be the impact. Again, not going into many details, but if you just focus on the efficiency, we're also improving the efficiency of the system, and we're also taking care of the sustainability aspects, right? Obviously, now we have reduced downtime. We can spin up CPs on multiple locations. And with that, what happens, you're just, first of all, directly impacting scope 1, because we are reducing the truck rolls. And second, obviously, because if you design a system in such a way, what you can do is you can optimize or take care of how you handle the resources. So what I want to say is it's kind of in the design. So when you start including that in your design, we can start making considerable amount of change. Now, this use case is actually taken from one of the projects that our CX team has been working on. Without going into technical details, just 3 points here. What's happening here is, number one, we're deploying day 0 configurations, provisioning it, and day 1, day 2 configuration with simple service that we apply. For example, it could be L3 VPN, ACL, costs. Second, obviously, NSO is a multi-vendor supported system. So we are doing multi-vendor orchestration, and also along with that, we are deploying on multiple sites at the same time. And third, if there is a service redeployment or service restoration, we can do that as well. And all of that impacts your sustainability. Now, this is something Bernard already spoke about, but I'll highlight a few more ideas, and then you can do the poll and add more ideas to it, I would say. Obviously, everyone has been talking about the kind of energy cost increase we've had. I've heard it's 4 times now than over the years. When I'm speaking to our SP or enterprise customers, everyone's asking, how much are my devices consuming? How much is my access point consuming? How much is my, each component of the network consuming, and how do I optimize it or reduce it? To do that, we put on our developer's hat and then start thinking, OK, first I need to measure it, normalize it. Obviously, there are a lot of steps to that. And then finally, we recommend and implement the solution. Right? Now, let's think of it this way, that let's see how networks were historically designed, right? They were designed to be powered on 24/7 to maintain the SLAs. Obviously, it was harder before because we did not have such software APIs and controllers which could predict the upcoming demand. But now, with the advent of these controllers, right, and the technologies in AI, what we can do is we can predict that when do we have demands coming up, when do we, when do we not need something, or how can we change it based on an algorithm? And according to that, what we can do is we can handle these sort of SLAs and redundancy as well, and take care of the power consumption aspect as well. OK, before going here, I think would like to tell you a story. Not a story, in fact, that happened to me last week. I was at a cafe, and I was, in fact, working on this presentation. And I got speaking with the owner of the cafe, who has multiple branches across Spain. And he tells me, what we do? We switch off our access points when the cafe is not working. And that's a work cafe, so they just have 8 hours of work. And then I was like, OK, that's interesting. But you can imagine the kind of saving that they can have, right? So it's like, instead of 365 days, 24/7, you're just doing 313 days, because they're off on Sundays, and just 8 hours, right? And he said, poco a poco, little by little. So like, yeah, this is interesting. And I was like, OK, if we apply this in our networks, in access points, right? And this is just an idea. Maybe if we start doing that, we can have a considerable impact as well. Now, I'm not saying there are not things to consider or there are no complications. Obviously, there are. There are many complications. But all of you are network engineers here, and I'm sure you have ideas on how can we overcome that. And then the ideas kept increasing. I was like, yeah, you can work on the line cards. You can work on the containers. We can work on ports, access points, fan speed, and so on. And the list goes on increasing. But then how do we do that? Let me give you a small example, because we've been working on projects, and this is what we're trying to do. So first, you scan the network. The first obvious step is measure. Get the measurement of what is it that we have today and what is our KPI. So set your KPIs. In this case, what's happening that we measure, say, for example, you see on the device level, we have the power usage and the CO2 emissions. We can do it per device level and then also infrastructure level, an extrapolated value. Then you analyze, right? Now, the analysis can actually have, let's say, many parts to it, right? You can have the architectural piece where you say that, OK, let's move to routed optical network, or let's do a topology refresh, or it could be environmental. Let's say you say that, let's change the whole cooling system, or it's overcooled. There's a case. Data centers are being overcooled. So you kind of only maintain the optimum cooling range. There could be more. It could be topology-based, node-based, traffic-based, right? And you can optimize your traffic, both considering your performance and the sustainability aspects. In this case, power consumption, OK? Obviously, there are unused ports detected in this case, in our example. Then it said that, OK, there was a higher power consumption by some of the elements. There was more heating. And then it said that, OK, some links can be optimized for better bandwidth efficiency. Then we have a recommendation based on that analysis. Now, if you see this recommendation here says, OK, we can have a selective depowering of the interface based on a particular time, maybe during off-peak hours. It could have a different logic as well. There could be a traffic policy so that it improves the efficiency and of the bandwidth and also reduces the power consumption. It could have another case like migration of devices, or even software upgrade, or moving to a different solution, moving to a virtualized system, and so on, right? When we've done the recommendation, then we do the implementation, and here's where our automation tools come into picture, because they're going to do that closed loop integration for us. So we have NSO, Crosswalk Network Controller, and we have WAI. And we already have a lot of examples with this. We have Steven and Guillaume who are going to deep dive into this and come and give us a demo as well and explain how things are working on this area. We apply these recommendations, and if you see what the kind of impact that we can have is obviously an efficient network, along with that low power consumption, which means dollar saved, and reduced CO2 emissions, right? Now, obviously, last time I spoke about the Sustainability Insights project that we've been working on. There's a lot more work done, and we can connect offline, and I can share more details about this. Now, I hope you remember the surfer girl. Now, she's also a developer, so she gets together with the team, and she's like, OK, I have an idea. Let me develop an app. So she makes a surfer app. And that app does two things. It does two sorts of recommendations. One is based on performance, and the second is based on sustainability. So it talks about the performance on how can the surfer improve his or her performance. It could be which location to surf at, which board to use, and so on. Second, sustainable recommendations. So it could be something like, OK, recommendations about the location, so that there are policy-level things that you can send back to the authorities, to the community, and so on. Or sustainable brand options like, OK, which sustainable board, rash guard, et cetera, that you can use. Now, the surfer is obviously happy once these recommendations are applied, because she's surfing in a more, let's say, cleaner beach, and also improving her performance. Now, obviously, we spoke about a lot of things hardware. Let's talk about what can happen if we move to a virtualized world. Now, this is, again, more from the design pillar, because you have to decide that, OK, Does it make sense to move to a different design? How can we do things differently? And so on, right? Now, let's say this app was being used on a traditional network with a 100 Gbps line, right? Now, it's predicted to have, this place is predicted to have one of the best surfs ever. And also, there's a surfing competition happening there. So what happens is that a lot of people gather up in that place. Obviously, since there's a competition going on, everyone's on the app. Everyone's checking what is the surfer's performance like, what's happening in the location, what's happening with the waves, and so on. And as a result, what happens that we hit the capacity limit, and the app slows down. But if we had a cloud setup, the performance of the network and the app would have been much better. Because on the fly, when we would have reached the threshold of capacity, we could have either changed the configurations of that virtual machine or that application, right? Or spinned up a new VM. And this could have happened at multiple locations. Now, this is something we've been using, and let's see how we could have done that. You might be familiar with this diagram. So what's happening here is, this is just a reminder, but what would be happening here is if you see the bottom one, right, which is the VIM, or Virtual Infrastructure Manager. So this could be your Cisco WIM, which is based on OpenStack. It could be AWS, Azure, and so on. Now, this is where your VNFs, Virtual Network Functions, or VMs, are hosted. Then on top of that, you have the ESC, which is the Virtual Network Function Manager. Now, this is the one which manages the life cycle of your VNFs, Virtual Network Functions, right? So this is the one which will predict that, OK, we've reached a threshold in terms of, could be anything, power consumption. Here, it could be capacity, right? Then the topmost is the orchestrator, Virtual Network Function Orchestrator, or NSO. This is where all the services is initiated from. So say, for example, in our previous example, when we detected and said that, OK, now we've reached the threshold and we need to upgrade or need to spin up another VM in a different location, your VNFM could have notified, and then your VNFO could have spinned up or provisioned another VNF. This is another example. Say, for example, in this case, let's focus on two things. What's happening is the VNFO is instantiating a VNF. Once that's done, at one point, your VNFM detects a fault. And it talks about performance. Maybe it could be memory leak, unusually high traffic, a security threat, or any of these parameters. There's something wrong from one of the sustainability pillars. Like, OK, this device has something off. It's heating a lot. It could be any of these things. And then your NSO, or VNFO in this case, could either send another service for its recovery or spin up a different one. Obviously, it will have impact on both the efficiency and sustainability aspects. Now, with VMs, what happens is that we use shared pool of resources. So you're also taking care of wastage, because now we're using less resources or optimized resources, and you have to take care of less devices in that way. Obviously, there is, it goes without saying, we have more flexibility and efficiency and so on. Obviously, I say reduced power consumption because less devices, then you can optimize that better as well. And less wastage or better equipment utilization. OK, now, I think everything else is history. Containers or containerization is something that everyone in our industry is talking about. The first thing that we learned about the workflow management yesterday was, oh, yeah, it's built on Kubernetes. But why is everyone wanting to do that? Why are leading industries and everyone just talking about it, right? So for doing that, let's understand a little bit on what's happening. So once upon a time, all we knew about was physical devices. And then the world was introduced to the world of virtual machines. And then came the containers with LXCs, Linux containers, and Dockers, which I feel kind of revolutionized the way we use Dockers or containers in the production environment. And last year, I think we said that with NSO as well, we have the CNFO package, and we're talking about it more and more in, like, say, for example, CNC is based on Kubernetes, and we are adopting that model more and more. While we are adopting that model, we take care of performance, and we've been talking about performance so much. I think there's another pillar that we can add, and we can see that how can we take care of metrics around sustainability as well. And I'm talking about few things, but I'm sure like all of you have so many ideas going on in your mind right now. It could be this, it could be that. How do we do a refresh? How do we take care of the materials? How do we take care of, there's so many things, right? So let's try to kind of understand this a little bit more before we start thinking about the design, right? So as you know how containers work, and you might have used the NSO container. So this package is being used in a SP environment, right? So we're running some services, and then this package as well is being used in a, let's say, instructor training center where we're using certain policies, like ACL policy to block URLs and so on. So your containers can run in isolated environments. It's environment agnostic, right? So you can just plug and play. It has a faster, it is faster deployment, easy to use, very lightweight and portable. That's something we know, right? And if you think about it, then you kind of start thinking that, okay, what's happening with that, right? Let's say, for example, before I go into this one, we've been experimenting with, there's something known as Quarkus for one of our controllers. That's a Java-based containerization platform. And what we do with that, and what we've seen, is that it really drastically improves the performance, right? And also, when we were testing, we were checking the power consumption values. And it had, from the traditional Java container setup, it had drastically gone down. So we saw that, okay, it was impacting performance, which I think I remember it was memory, and the second was faster deployment or something. And both of these aspects were like we had great numbers. And also with power consumption, we had really great numbers. If I remember correctly, it was 40%. And if I think about another white paper I was reading, in fact, just last week, that was from this company called Netflix. Might have heard of it. And they have built their container platform, something known as Titus. And they spin more than 1 million containers each day. That's something to think about, that why are all the leading companies moving to containerization? And as we start doing it, let's start including all the parameters, and that could make a lot of change. Like in this example, in this setup, we had many containers, right? So what we do is that we say that I have some space in my hardware, so I'm going to also use, because this is my own system, so while I was, let's say, testing NSO, I was like, okay, let's also use the tide, wind, and beach location containers that we can use in the surfing app. Now, all of these components or containers can be used in the analytics engine of the surfing app. But not just that. This is reusable, because the wind container here could be used in the surfing app, but it can also be used in the windmills app that can be used in Sweden, for example. OK, now, there are two things in this case. So obviously, first, we spoke about performance in terms of portability and flexibility. So this obviously is giving so much portability and flexibility. The second is also resource usage. So if you see this hardware bare metal, and initially, obviously, if we go down the memory lane, we were just using hardwares. So when we were using hardwares, what would happen is that one hardware could run only one application. So no matter how much you would want to use the application or how little you use the application, you're using this whole hardware. So in one case, you're using maybe only 20% of the hardware for one application. And if you wanted to have another application, you would deploy another hardware. But things kind of start changing with virtual machines. Now, what started happening is, obviously, as you know, virtual machines use their own guest OS, own virtualized hardware. So one application per virtual machine. Now, what's happening here is that in one virtual machine, you start using one application, then you use it to a certain level. Then if you want to come up with new applications, you have more VMs. So you're utilizing your hardware resource a little better now, right? So in this case, if you see you're using it, and then your hardware resource gets utilized to 60%. Now, in case of containers, what happens is that containers, as you know, use the kernel of the OS, right? But they work on separate user spaces. So with this, you might have a little better performance than in the case before. But obviously, there are a lot of ways to kind of tweak it depending on how you write your code and so on. But then you can come up with more and more containers. And this will have much better utilization in terms of your hardware. So maybe now we need less resources or less devices, which also means less wastage in a way, apart from obviously performance and taking care of other parameters like power consumption and so on, right? And that's what I'm depicting in the slide here. Talks about all of these things: lightweight, portable, better resource utilization, wastage, and lower power consumption could be the case as well. Now, obviously, no one shoe fits all. When we're designing, we need to come up with a middle ground. We need to see what we can do. So in this example, you see that I have the hardware resource. Now, we have a VM on top of that. But now a VM can have multiple applications. And how? With containers. We have containers on top of VM, and that's what we're generally doing, right? And then now, each single VM is now better utilized. So if I need to have more applications, I maybe deploy more VMs, depending on how I want to set it up. But in this case as well, what ends up happening is that a resource is still better utilized as compared to 4 VMs. Now, this example, right? And I think in CI/CD pipelines, that's somewhere what we do. We try to come up with middle grounds, and we try to automate the process and check something out like that. OK, we spoke about a lot of things. I have many more ideas we've been trying to do. It could be traffic optimization. We have Guillaume presenting that soon. We have auto capacity management, cell-side provisioning. There could be many more things. So what's your idea? In the Slido, you can go and enter your idea as well, and I'll be waiting for that. OK, let's summarize now quickly, because I'm already over time. So I'm going to make it quick. We have an infrastructure. The first step is we do a data collection. Let's do it with my favorite Surfer app. We collect data about, for example, wind, tide, temperature, so and so, many things. Then we measure the data, normalize the data if required. We analyze the data. Then we recommend the data using a prediction algorithm, and then finally implement the data. Now, I'm going to leave the slide here for a second. And let's imagine a network infrastructure. And our aim is to have definitely a high performance. I mean, that goes without saying, but also a better and more sustainable infrastructure. And that has a lot of plus points as well, right? Even in terms of policies, and why do you think so many companies are now also pushing for that? So there are a lot of reasons why we need to have such sort of an infrastructure. So the first step is we do some sort of data collection, right? So we have some dynamic data that we collect from our devices. There's some static data that we collect. Static data could be your, how the device is in terms of circular economic values. Dynamic data could be temperature, traffic, blah, blah. Then you measure the data, you normalize the data, then you analyze the data, and then we recommend the data using a prediction algorithm, which uses a learner agent, because now you want to also use the best practices, right? And then you want to compare and see what we have in our system, what is the best KPI or best practices that we want to include, and using that, we want to recommend a solution that can be implemented using our automation tools, and voila, we might have a better system. So only 3 things to remember. from the session. Number one, do you have a sustainability KPI? And what's your sustainability KPI? Second, it's all in the design. I would say, as you're including performance, as you've been including many other things, even like cost reduction and so on using automation, include this pillar as well in your design from day zero. And number three, collaborate with us. Thank you so much.